Okay, this whole section is on solving equations that involve these trig functions, and sometimes we'll be using our trig identities, but for right now, we're not really. Alright, so first off, find all solutions. So I'm just going to treat this like a normal equation. I'm trying to get to the x, so I add 1 to both sides. So I have 2 sine x equals 1. Divide both sides by 2. I have sine x equals 1/2. Okay, so to get rid of the sine, I'm asking where does sine equal 1/2? So I think of my unit circle. Sine is my y value. Go downstairs. So sine is 1/2 should be right here and right here. So that is at what, pi over 6 and 5 pi over 6. But I'm finding all solutions, so couldn't I go around a full circle? So if I added 2 pi to like a coterminal angle, and I would end up with 13 pi over 6 would also work. So when I write my answers out for pi over 6, since my period for sine is 2 pi, I have to say plus or minus 2 in pi. So that means I could be adding and subtracting a full circle, a 2 pi, any number of times where n is any integer. I also have to do the same thing with my 5 pi over 6. So I have pi over 6 plus or minus 2 in pi, and 5 pi over 6 plus or minus 2 in pi. And those are my two answers for the first one. Second one, find all solutions in this interval. So I'm only looking between 0 and 2 pi. The bracket on the 0 means that 0 is a possible answer. Parentheses the 2 pi means it cannot be an answer, because 0 and 2 pi would be the same point on the unit circle. I'm actually using the 0 if that's my answer, not the 2 pi. On this one, need to get my x's on the same side, so maybe I just subtract the sine x. There we go. Over to the sine. Sorry about that. Okay, so I'm left with square root of 2 equals negative 2 sine x. Divide everything by negative 2. I end up with negative radical 2 over 2 equals sine x. So I'm thinking about my unit circle. Sine is y values, so negative is going to be down here. Radical 2 over 2, sorry, negative, yeah, radical 2 over 2 is going to be at 5 pi over 4 and 7 pi over 4. Because I just want the answers between 0 and 2 pi, I do not need to do the plus 2 and pi. These are all of my possible answers that fall within that one revolution of the unit circle. So x equals 5 pi over 4, and x equals 7 pi over 4. Alright, I have a tangent squared here. Still trying to get to my x, so add 1 to both sides, so I end up with 3 tangent squared x equals 1. Divide everything by 3, I end up with tangent squared x equals 1/3. When I do the square root of both sides, I'm going to end up with tangent x equals plus or minus square root of 1 over 3. Square root of 1 is just 1. Square root of 3 is just going to stay like that, radical 3. I would need to rationalize that, so I'm looking at plus or minus radical 3 over 3. And then I'm asking myself, where on my unit circle is tangent, which is y over x, going to be radical 3 over 3 in all 4 quadrants, because I want the positives and the negatives. Let's see, so I know it's either going to be at my point, that is 1/2 radical 3 over 3, or again with positives and negatives. Radical 3 over 2, my fault. Or it's going to be at the ones that are radical 3 over 2, 1/2. Again, positives or negatives. So I'm just going to try y over x. I'll do this one. If I do 1/2 divided by radical 3 over 2. Over here I'm doing radical 3 over 2 divided by 1/2. So remember, when you divide, that's really like 1/2 times 2 over radical 3. This one does give me 1 over radical 3. Whereas this one would just give me radical 3. Alright, so I want the ones that are, the x value is radical 3 over 2. So that's here at pi over 6. It would also work for a negative radical 3 over 2, so that would be at 5 pi over 6. It would also work at 7 pi over 6 and at 11 pi over 6. Because I asked for the positive and negatives for tangent, since I did the square root, I have to include all of those. This does not specify to stay within that 0 to 2 pi range, so I have to do all solutions. So when I start and I say x equals pi over 6, my period for for tangent is just pi, so that's plus n pi, which actually pi over 6 plus pi handles the 7 pi over 6. So I don't have to list that one again. X equals 5 pi over 6 plus n pi, and 5 pi over 6 plus pi would get me 11 pi over 6. So this actually covers all of my solutions within the unit circle as well as without. Alright, this is the last one we're doing. We're solving this. Yes, there's cotangent on both sides, but if I divide by cotangent of x, I actually end up getting rid of one of my answers. So as soon as I start seeing like squareds and stuff, I think of it just like I would with a quadratic. I'm going to try to get everything on the same side and get it equal to 0. So cotangent x cosine squared x minus 2 cotangent x equals 0. From there, I would factor out my cotangent x, so factoring is definitely still something we're still going to do. I have cosine squared x minus 2 equals 0. Now I have two things multiplied to equal 0, just like when you used to factor with quadratics. So I set each of these equal to 0. And then I'm solving. So cotangent, I need to know, there's nothing else here, so just where does cotangent equal 0? So I'm thinking about my unit circle. Cotangent is x over y. So if I'm getting an answer of 0, then x has to be 0. So I'd be up here at pi over 2 and at 3 pi over 2. When I say that x equals pi over 2, and again I'm doing plus n pi, since that's my period for cotangent, and this said nothing about staying within 0 to 2 pi, pi over 2 plus pi would actually cover that 3 pi over 2. So I don't have to list it again. I'm good there. Over here, cosine squared x equals 2. So cosine of x equals plus or minus the square root of 2. But the square root of 2 is more than 1. And if you remember your range for cosine, when we graphed them, was at 1. Like it never went above 1 and it never went below -1. So this is actually not going to work because it's outside of the range of cosine of x, because that was -1 to 1. So pi over 2 plus n pi is my only answer. Remember, treat these like equations trying to get to the x, and you are just trying to figure out where in your unit circle, once I get down to just the trig function, where does that hold true?